29, we're doing a medical study. Are low-fat diets or low-carb diets more effective for weight loss? A sample of 78 subjects went on a low-carb. Oh, wait, there's two different diets. So this is two samples, right? So let's be very organized here. So let's say low-carb, low-fat. So low-carb, N equals 78. The sample mean weight loss was 15 pounds. Sample standard deviation 7.77. Second sample, N equals 74, went on a low-fat diet. Their mean weight loss was 16.3 pounds. Sample standard deviation, sample standard deviation was 6.10. Can you conclude that the mean weight loss differed between the two diets? Alpha 0.01. Okay, so we're going to do the whole process here, right? I'm going to do the whole process and then kind of answer the questions in there. So here we go. So step 1. State the null and alternative hypotheses. And this is actually the answer for part 1. So null hypothesis is that these two diets, the means for these two diets don't differ at all. They're actually the same. Mean 1 equals mean 2. Or you can also say mean 1 minus mean 2 is 0. Right? We spoke about that in a problem before. Alternative hypothesis, mean weight loss is different. So mean 1 is different from mean 2. Or mean 1 minus mean 2 is not 0. Null and alternative hypotheses. Step 2 says critical values. Maybe one value, maybe more than one value, right? So I'll draw my little picture here. So then, since we're saying differed, this is going to be a two-tailed test. Since it's not equal to, two-tailed test, right? Okay. Alpha is 0.01, two-tailed, 0.01, two-tailed. Let's see. And this is not a z-test. This is a t-test, right? So let's look at something before we go there. So this is a two-sample t-test, right? T-test, right? For two samples, two means. The degrees of freedom for that is the smaller n1 minus 1 or n2 minus 1. So whichever one is smaller, so the degrees of freedom is going to be 74 minus 1, which is 73. That'll be the degrees of freedom for this situation, right? So that'll be the degrees of freedom. Now this problem purposefully doesn't ask us to do that, but that's okay. So this degrees of freedom actually answers the third question, right? Okay, so let's go. So 73 degrees of freedom, 0.01, two-tailed, right? T-test table. Two-tailed, 0.01, is that what we said? Yep, alpha's 0.01. Two tails, 0.01, 73 degrees of freedom. We don't have 73. Choose the closest value because these aren't so different, right? Look at, come on, give me 75. Look at 70. Can't tell which one. Is that it? Yeah. 75, look at 70, look at 80. They're very close, right? So use the closest one. 75 is the closest to 73. So use 2.643. 2.643. So 2.6.643 here, negative 2.643 here. Okay? Good so far? So if when we compute our test value, if my test value is in this region or this region, reject the null hypothesis. So let's calculate our test statistic. So T, and it's a pretty involved formula to calculate the test statistic here. Much nicer in the calculator, which I'll show, of course, but here we go. I hope I remember this. So T equals x bar 1 minus x bar 2 squared minus mean 1 minus mean 2 squared over the square root of S1 squared. Oh, I forgot it. S1 squared over N1. Yeah, that's what I thought it was. And the numerators are not squared. Over N1 plus S2 squared over N2. Peek back. Yep. Okay. Okay, so 15 minus 16.3 minus, well, the mean 1 minus mean 2 is 0, so that's 0 over the square root of 7.77 squared over 78 plus 6.10 squared over 74. I'm going to put this all on my calculator. Trusty calculator. So in my numerator, I have 15 minus 16.3 divided by, the nice thing about the square root is it encapsulates everything already. So 7.77 squared divided by 78 plus 6.1 squared divided by 74. And my T test value is negative 1.15. So we see negative 1.15 is somewhere here, isn't it? See, it's not in the rejection region. So step 4, do not reject the null hypothesis. Step 5, well, which one was the claim? The claim was that they differed. Here's the claim. Okay, so the conclusion is 5. So we don't reject the null hypothesis, so there's not enough evidence to support that claim. That mean weight loss differed between the two diets, etc., etc. So that's how you do this out a hand. So to answer the questions, right? We got the null and alternative hypotheses. Here, the test statistic, T equals negative 1.15. Degrees of freedom, 73 of them. Do you reject the null hypothesis? No. And number 5 is why. That's the conclusion. You can do this in the calculator too. If you go to stat to do some statistics and you go over to tests, because we're doing a test, hypothesis test, this is a 2-sample t-test. All right. If it was a z-test, we would have the population standard deviation. 2-sample t-test. If you're given the data and you have to calculate everything, that's data. But here you're given the statistics. If you're given the data, you would enter them into your list L1, L2, or whatever list you want to use. But we have the statistics. So X bar 1 is 15. Standard deviation 1 is 7.77. N1 is 78. X bar 2 is 16.3. Standard deviation 2 is 6.1. And N2 is 74. We're doing a not equal to test. Don't worry about that pooled. Calculate. We've got our t-value, negative 1.15. Don't worry about that degrees of freedom. That's a different calculation than we use. If you're using the p-value method, this p-value 0.25 is greater than alpha. 0.25 is greater than 0.01. So do not reject the null hypothesis. You still get the same conclusion.